that have actually mitigated global warming. They have actually produced a cooling of the planet. Paleoceanography essentially is the study of the ocean from a geological past. In my case, I'm mostly interested in the relatively recent past, essentially the transition from the last ice age to the modern. We went through a series of abrupt climate change that must have been associated with change in ocean circulation. When we retrieve the pump on deck, then we can actually put a vacuum. What I'm trying to do is develop some geochemical traces that I can measure in the sediments that would tell me when and by how much the ocean circulation has changed. What we have learned is that indeed there was some very abrupt and very dramatic change in ocean circulation associated with this abrupt climate change during the last deglaciation. We have to be concerned because there is a decrease in salinity that has been observed in the last 40 years in the North Atlantic. So you had fresh water in this region, and as a result of that, because fresher water, lower salinity water is less dense, it's more difficult to produce this deep water, and potentially this circulation could slow down. The footprint of a change in ocean circulation is pretty much global. So you evidently have cooling of the northern continents, because this is a mechanism whereby you bring heat from the lower latitude towards high latitude. And this will slow down, so there will be less heat being brought to those regions. Therefore, that will cool down. So greenhouse warming results from the fact that there is some trace gases in the atmosphere. The reason why I work on this is because I am interested in looking at the big picture. And I like to see the interaction between the ocean, the atmosphere, the chemistry, the biology, the physics. All they actually come together to produce the world as we know it.